Good afternoon, everyone. My name is Bob Klinger. I'm a Senior Product Manager in the CASE Group here at Univar Solutions. I would like to thank you for joining the Adhesive Spotlight series. Today, we are featuring Kraton Polymers. We here at Univar Solutions are serious about safety and start each meeting with a safety share. Today, I'd like to talk about autumn home safety tips. First and foremost, we'll be driving in changing weather conditions. So things like rain, snow, fog, ice, sunlight, and wet leaves are only a few of the dangers you can encounter over the roads. So slow down, be aware of your surroundings and possible changing conditions. Secondly, use caution when using a ladder, especially to clean gutters this time of the year. Wearing appropriate footwear is important because shoes and boots can get wet, causing you to slip as you also make sure that the ladder is positioned on a flat, stable surface before using. Clean up fallen leaves in your driveway and walkway. Wet leaves can create a hazard for pedestrians and making walkways slippery. Make sure that your furnace is working. Call your heating and cooling contractor to inspect and service your furnace this time of year. A specialist should be able to inspect the furnace and make sure that everything is in working order and working safely. And finally, avoid burning leaves. In many places, burning leaves is illegal, but also it can release dangerous chemicals into the air. So try to find another way to get rid of them. At the very least, if you have to burn them, do so wearing a mask. I hope these reminders will keep you and your family safe to enjoy the beautiful colors of autumn. During today's session, you will be able to submit questions using the chat box feature. The way to use this tool is simple. First, click on the question box as indicated in this diagram and type your question into the box on the bottom. Only the presenter will see the question and you will remain anonymous to the other attendees. You can submit questions at any time during the presentation, but we will have our presenters address as many as possible at the end of the presentation. Now I'd like to introduce you to today's presenters from Kraton, Aaron Brothers and David Truong. A little background on our presenters. Aaron Brothers is a senior R&D scientist at Kraton Polymers. Aaron is an application-focused scientist with over 10 years of industrial experience in polymer technology. Aaron has delivered innovative solutions using styrenic block copolymers to customers in a wide variety of market segments, including adhesives, sealants, coatings, and oil modification through collaboration and customer engagement. Aaron has a strong skill set in polymer formulations, material characterization, technical service, and application development, where he has successfully leveraged his experience to create new opportunities for Kraton in the polymer industry. David Truong received his doctorate in chemical engineering from the University of Houston with his research focused on structure, property, processing relationships of membranes made using Kraton's Nexar polymer. He also received a Bachelor of Science in Chemical Engineering from Clemson University. David recently joined the Kraton Specialty Polymer R&D team as a scientist, where he provides technical support to customers and drives innovative projects involving styrene block copolymers in market segments including automotive thermoplastic polyolefins, engineering thermoplastic modifications, adhesives, sealants, and coatings. Both Aaron and David are based out of the Kraton Innovation Center in Houston, Texas. Thank you to both Aaron and David for joining us today, and we look forward to today's discussion titled High Performance Solutions for Adhesive Applications. Now I'd like to turn the webinar over to Aaron.
Thank you, Bob. Today we will cover high performance solutions for adhesive applications. David and I will focus on a very brief company overview, followed by advancements in high melt flow HSBC polymers, as well as a brief mention on a couple new USBC grades. Kraton is a leading global producer of specialty chemicals, and we develop, manufacture, and market specialty polymers and bio-based chemicals that deliver exceptional value and enhance the lives of people all over the world. We have a high commitment to customer service and research and development activities and continue to focus on innovative-based solutions for our customers and communities. Kraton has a long history of groundbreaking innovations with a significant support network company-wide. We have a vast global footprint that spans multiple regions, and we have manufacturing, R&D, and commercial offices throughout the world. David and I are based on our flagship Innovation Center in Houston, Texas, and provide support to our HSBC manufacturing facilities that are located in Belpre, Ohio, and Mailiao, Taiwan. Our facility in Taiwan is the largest HSBC plant in the world, and many of our newest HSBC polymer products are produced in the Belpre and Mailiao. Kraton also achieved an EcoVadis Platinum level sustainability rating in mid-year of 2021. This acknowledgement highlights Kraton's ongoing commitment and dedication to sustainability throughout our company as we work to address our evolving market needs. The origin of Kraton goes back to the development of synthetic rubber in the 1940s, and the first thermoplastic elastomer was a styrenic block copolymer developed in 1961. Today, we continue to be a leader in global manufacturing SBCs that deliver both strength and elasticity, along with bio-based chemicals that enable replacement of non-renewable resources with high-performance sustainable alternatives. Together, our products serve a vast array of market segments, and today we will focus on polymers for the adhesive applications. Kraton has over 60 years of innovation and growth, and our products are part of daily life. For example, our polymer products can be found in applications such as automotive, medical, packaging, consumer products, paving and roofing, adhesives, sealants, coatings, among many others. So what are styrenic block copolymers? Styrenic block copolymers are thermoplastic elastomers that are both strong and soft. Typically, they consist of polystyrene end blocks, which are often referred to as the hard phase, and a rubber mid-block, often referred to as the soft and flexible phase. The hard phase has a high glass transition temperature near 100 degrees Celsius and is incompatible with the softer rubber block. This phase provides strength due to the physical crosslinks formed and remain at room temperature. The diagram in the upper right illustrates the polystyrene block domains that form the physical crosslinks, creating a strong 3D network. Physical crosslinks have the advantage in that they can be reprocessed and reformed, unlike systems that utilize chemical crosslinks. The flexible phase also has a low TG, great oilability, and provides elasticity. The TEM micrograph illustrates the polystyrene domains as dark circles encompassed in a continuous rubber network phase as indicated by the lighter regions. In this example, we have a rubber mid-block between polystyrene end blocks. When the rubber block is based on polybutadiene, it is called an SBS for styrene butadiene styrene polymer. In this case, the polybutadiene consists of double bonds and is part of the USBC class of performance polymers, also known as unhydrogenated styrenic block copolymers. These polymers are used in several applications and can also be chemically cross-linked. Also, we can hydrogenate the polybutadiene rubber block and produce an HSBC, also known as hydrogenated styrenic block copolymer. When the polybutadiene block is hydrogenated, it is typically referred to as an EB block since it has similar structure to hydrogenated polyethylene and hydrogenated polybutylene, hence the term SEBS. Hydrogenation provides the advantage of enhanced UV and thermal resistance breakdown compared to the USBCs. Adhesives are a strategic focus and growth area for Kraton. We are committed to increasing value to our customers and providing sustainable solutions with our knowledge and experience in chemical and polymer technology. Now I will hand it over to David to discuss a couple of our newest HSBC grades.
Thank you, Aaron. First, I would like to talk about the Kraton MD1648 product, which is a low viscosity SEBS polymer. Now, this is a new polymer that Kraton developed that can be used in adhesive formulations. MD1648 is an ERS grade, where ERS means enhanced rubber segment. MD1648 is one of the smallest molecules in the Kraton ERS family. It is 10 times lower viscosity than the G1643. The low viscosity and the high melt flow enable easier processing and the potential to reduce cycle time and lower processing temperatures. The polymer also provides improved dispersion in master batch and adhesive formulations. This molecule also makes it possible to make oil-free compounds. And finally, this grade is of particular interest in modifying polyolefins, especially polypropylene. MD1648 represents a high melt flow platform, and Kraton has made a capital investment to bring this grade to the industry. It has an extremely high flow properties beyond 200 degrees Celsius. It is also softer, very elastic at 750% elongation. The chart here shows the comparison between MD1648 and other ERS grades. In addition to having a much higher melt flow rate, MD1648 offers comparable tensile strength and hardness. It also has a product form of dense pellets, making it easier for processing. There are three key features of MD1648, which makes it an attractive grade. The first feature is the step change in the lower viscosity makes it easier to disperse, requiring less temperature and pressure. The high melt flow of this grade means that it can be used as a carrier, master batch, and does not require flow modifiers or plasticizers, such as oil. And the third feature is that the microstructure is very compatible with polypropylene, provides an excellent transparency, and can also serve as an efficient polypropylene impact modifier. Here are some experimental analysis of the MD1648 that provide understanding of the polymer itself and how to process it for success. On the left side, the DMA results show a two-phase structure with a relatively low TG of negative 19 degrees Celsius. And on the right side, you can see that MD1648 has a lower order disordered transition temperature compared to other more conventional grades, allowing this material to be processed at a lower temperature and therefore can become a single phase much faster. MD1648 can be used in a variety of applications, such as low viscosity hot melt adhesives, textile adhesive with improved adhesion strength, low viscosity hot melt pressure sensitive adhesive labels, low viscous tape formulations that are oil free. And finally, MD1648 can be used as an impact modifier for polypropylene and also as an enhanced dispersion in polypropylene. So MD1648 can enhance the performance in hot melt adhesives. The table here shows two APAO formulations, one with MD1648 and one without. And as you can see, an improved performance is observed by adding the MD1648 polymer, especially enabling higher shear adhesion, failure temperature, and holding power. And in addition, MD1648 offers a good color stability after heat aging. MD1648 can also be formulated into a hot melt adhesive for textile applications. The table here shows the melt flow rate and adhesion strength to nylon textile for MD1648 with and without adding the tackifier. And you can see that the adhesion strength can be doubled by formulating MD1648 with a tackifier, and the melt flow is also significantly higher. In addition to improving adhesion strength in textile, MD1648 can also optimize viscosity in hot melt pressure sensitive adhesions for labels. The chart here compares the performance of two formulations, one with MD1646, which is the green one, the green bar, and the other with MD1648, which is the dark blue bar. And using different testing methods, such as Q adhesion, loop tack, shear adhesion failure temperature, holding power, and you can see that the MD1648 achieves very similar adhesion performance compared to MD1646, but the MD1648 offer a much lower hot melt viscosity. MD1648 also offers formulation flexibility in hot melt pressure sensitive adhesive polymer blends. This table here shows 6 different formulations with loading range from 0 to 30 parts per 100 rubber for MD1648. And the samples were prepared using either solvent coating or direct coating methods. And the performance of these formulations were evaluated using different adhesion methods, such as loop tack on stainless steel, 100-degree peel on HDPE and stainless steel, as well as shear adhesion failure temperature. Here we show the viscosity range of the 6 formulations from the previous slide, and you can see the formulation 1, which has the highest loading of the MD1648, offers the lowest viscosity. In addition, compounding of adhesive made with 1648 also requires less mix time, while making no detrimental effects to the adhesion performance. And therefore, MD1648 provides the flexibility for adhesive manufacturers to tailor their formulations that are suitable for their needs. To sum up, MD1648 is one of the highest melt flow polymers and lowest viscosity Kraton SEBS grades. The polymer is currently being used in solvent cast and coatings, melt extrusion, and injection molding processes. A broad range of adhesives can be made with MD1648, and the soft touch makes it an excellent candidate for textile adhesive, flexible coatings, low tack protective films, and elastic melt-blown non-woven fabrics. MD1648 is particularly compatible with nonpolar substrates and polyolefins, both polyethylene and especially polypropylene. It can also improve impact properties, increase melt flow, or soften polyolefinic formulations. Next, I would like to talk about the MD1623 product, which is a new developmental SEBS grade with ultra-low viscosity. And this is a unique and novel polymer that can also be used for adhesive formulations. As an effort to broaden our portfolio, Kraton has made an investment in commercial capability to create a high-flow ERS polymer that is easy to process and also is more compatible with many polyolefins than other Kraton polymer families. One of those developmental projects is MD1623 grade, which can offer very high flow rate and ultra-low viscosity. This molecule has been in several test runs at Kraton Semiworks, and the properties have also been characterized. Operational evaluations call for commercial scale, shows manufacturing feasibility, and we are currently having discussion with customer to explore the potentials. Here are some of the properties of the MD1623. It belongs to the enhanced rubber segment family with a polystyrene content of 34%. The melt flow can get up to above 1,500 grams per 10 minutes, which is a very high value. The tensile strength is measured at 5 MPa, and the polymer is also very elastic with a 700% elongation at break. And finally, the polymer comes in dense pellet form, allowing for easy processing. This table here is a summary of the new high flow polymers compared to some classic and well-known Kraton G grades. And as you can see, the MD1623 has the lowest viscosity and the highest melt flow rate compared to the other high flow SDBS grades. Again, this allows for easy processing and also is compatible with many non-polar substrate. The table also demonstrates our design expertise to deliver many polymers with a variety of performance. In conclusion, the MD1623 offers a multitude of benefits, such as having an ultra-low viscosity that can be used in many potential applications, such as hot melt pressure sensitive adhesives, hot melt polyolefins formulations, sealants, and more. MD1623 offers a wide range of compatibility, such as polyolefins, hydrogenated and partially hydrogenated tackifiers, as well as paraffinic oils. And finally, if you are interested for samples, please reach out to your Kraton sales manager. And now I would like to give the floor back to Aaron, who will introduce other polymer grades that we have.
Thank you, David. Now we will go into one of our other new HSBC grades termed G1653. So Kraton's precision chemistry allows smaller molecules, which improves processing and leverage capacity. G1653 is smaller compared to our conventional G1652 product and may be of particular interest to solvent and hot melt-based systems. The lower viscosity and higher melt flow enables easier processing and the potential to reduce cycle times. G1653 may also be used with some exempt solvent systems to help meet regulatory standards and possibly enable VOC reduction. It also comes in a dense pellet form, which is easier to handle than polymer crumbs, as some of the other grades that David mentioned previously. G1653 has a lower solution viscosity, which means it's easier to process, and as a result, the melt flow rate also increases. Yet most of the other properties remain the same as G1652, for example, PSC, hardness, tensile strength, and elongation. So in this table, you can clearly see that G1650 compared to G1653, G1653 has a much lower solution viscosity, and hence it will also have a much higher melt flow for the hot melt-based systems. And yet a lot of other properties are very similar. For example, hardness, ultimate elongation, the majority of the tensile properties. And again, another primary difference is the crumb. G1652 usually comes in a crumb form where it generally needs to be deblocked prior to use, whereas G1653 comes in a pellet form. So the operating box for G1653 is also wider than that of G1652. So this allows greater formulation flexibility. So here, two knobs can be turned to achieve performance attributes. For example, in A, the polymer concentration can be maintained at say 30%, and the viscosity will be lower with G1653. Lower viscosity may lead to lower pressures, which may reduce cycle times or reduce operating system costs. The second knob, which was B in this graph, is maintaining similar viscosity, yet we increase the solids content from 25% with G1652 up to 30% by switching to G1653. Therefore, this could lower the amount of solvent used and result in less VOC in the coating. Here, we also have G1726 just used as a reference because it also has lower viscosity, but we realize that the strength and flexibility of G1726 does not equal that of G1652 or G1653. This rheology plot reflects the step changes in viscosity and shear rate between G1652 and G1653 in the hot melt. Typically, lower viscosity and higher shear is preferred and may offer potential energy savings. Several applications have been selected as examples of the commercial successes for G1653 in the marketplace. Just some examples are here on the slide. For example, sealants, hot melt adhesives, solvent-based adhesives, feminine hygiene applications, and there's potential other applications as well too. So some of the primary benefits in HSBC in general, so especially with G1653, but other HSBCs, the benefits include weatherability, paintability, very high moisture resistance, long service life, great elongation, high strength, low temperature resistance. But some of our newer low molecular weight polymer grades, such as G1653, as well as MD1648 and the other ones David mentioned, enable possibly lower VOC contents, which is better for the environment. That also could provide system cost savings. Also, a higher solid content typically results in less shrinkage of the coating or the sealant or the adhesive. And then also the adhesion to a wide variety of substrates can be tailored, including during wet conditions. And of course, the products can also be clear for those applications that are sensitive to haze and clarity. So the smaller molecule design and lower viscosity is leveraged to lower application temperatures for hot melt adhesives. So this can reduce the oxidation and degradation that does occur at higher temperatures. In a personal care application, the raw material lightweight weighting is more sensitive to application temperatures for hot melts. So the viscosity of G1653 is leveraged to reduce the application some 30 degrees in this section here. Again, comparing G1652 in a hot melt with G1653 in a hot melt. This lower application temperature could benefit energy consumption as well as applications that may be more temperature sensitive. And yet if you look here, some of the properties are quite similar, although sometimes we will see a slight decrease in upper temperature strength with G1653 compared to G1652, if that happens to be a concern. So G1653 provides good adhesion properties for surface protection films as well. A wide range of surfaces can be covered from one step of production to another. It helps provide low peel strength, which is typically important so the film is not aggressive with a part being protected. It's also ideal for the adhesive to build low adhesion strength over time. The more aggressive the adhesive, the more likely residue is left behind and has to be removed before the next step can be initiated. Some additional G1653 benefits are also that that's good for protective films that are also mixed with PMMAs, PETs, PSCs, polycarbonates, or if those are the substrates. So again, it's a great combination of both low peel strength and low adhesion buildups. In this graph, again, we have similar data that David showed previously, where we're just comparing G1650, which is a more conventional Kraton G grade, with, in this case, is G1653. And so again, loop tack properties, peel adhesion properties, even the SAF properties are relatively similar with G1653, but we also get much lower hot melt viscosity, right? And that's kind of where we're looking here. If there's a system that enables lower viscosity, then this could be reformulated or possibly tailored to even boost these properties further if that application had that desired set. So the key message for G1653 is that it is a high flow Kraton G polymer and is a smaller molecule than many of the other classic G grades like G1657. Commercial successes have been achieved in both solvent and melt extrusion systems. In the solvent-based systems, such as sealants and coatings, a higher solid content can result in reduced VOC, also less shrinkage and potential system cost savings. And then a lot of our polymers are compatible with exempt solvent systems, and that can deliver even better environmental solutions. In the melt, lower application temperatures help enable the use of down gauge materials and energy savings as well. And these polymers also enable both low peel strength and low adhesion buildup, as well as great UV resistance because these are fully hydrogenated grades. So now we're going to cover some, just briefly cover some USB-C developments for these applications as well. So here, Kraton meets adhesive demand for non-wovens. So a non-SBS polymer is MD1156, and it was specially designed for the hygiene industry, but it may have applications outside of that industry as well too. So it typically shows lower viscosity, and at low viscosity is also at coating temperatures of 140 to 150 degrees Celsius. It should be easy to spray on sensitive substrates. It has better cohesion with a lower viscosity compared to other SBC polymers such as Kraton D1155. It also shows good thermal stability for hot melt based systems as well. So just another tool in our toolbox, so to speak. If one customer, or if you're using MD1155 or D1155, I'm sorry, MD1156 may be another good option. One of our other newer polymers, it's kind of a remake of one that we had in the past, is Kraton DX0222 polymer. So this is a unique polymer that suits itself very well to a radiation curable alternative where it's possible to make solvent-free adhesives. And so it has a unique polymer design. It still has good processability. It has good pressure-sensitive adhesive properties on a wide range of substrates. And the big key to this particular product is that it has high temperature performance after radiation curing, and that could be either via UV curing or electron beam curing, which again would be a solvent-free process. So radiation curable SBSs are great for high temperature applications, or those applications that need higher temperatures where the HSBCs or other typical USBCs cannot provide. So it's a reactive polymer that remains stable in typical hot melt processing systems. It's also a radical reaction reducing photoinitiator. So in other words, you can UV cure it. And the UV curing system is appropriate for most of the UV spectrums out there. It is well compatible on disperse and adhesive formulations, so it still acts like a typical Kraton SBS. It just lends itself very well to UV cross-linking, which again really provides higher temperature resistance. Since we are bringing this one kind of back, so to speak, this is one of our newer grades again, and so just again, yeah, ask us or ask Univar representative or Kraton representative if you need samples of that. And this is just some of the data that shows that the properties are still somewhat similar. So before cure, so like tack is still similar, the peel adhesion still similar on different substrates. Here we have stainless steel versus HDPE. Yeah, even when it's uncured, the hot melt viscosity stability is still relatively stable over, at least in this case, 24 hours. And again, the big key here is once we cure it, it provides a much higher temperature for the application, such as SAFT and better holding power as well too, compared to an uncured system. So just to sum up, DX222, again, it's really for high temperature applications, provides excellent adhesive properties after radiation curing. It has low stable hot melt viscosities. And again, it can be formulated along with a lot of our other HSBC and USBC grades with a variety of other ingredients and a variety of tackifiers. So to sum it all up, Kraton values sustainability, innovation, and its customer and technology base. Kraton polymers allow enhanced processability, formulation flexibility, improved performance, and can fit many end-use applications. Many of our products also have FDA clearances and can be recycled and reprocessed. Thank you for your attendance, and we look forward to answering any questions you may have. With that, I'll give it back over to Bob.
Thank you, Aaron. Thank you also to David for a great discussion. At this time, we're going to open it up for questions. Just as a reminder here, you can submit questions via the chat box feature in GoToWebinar. Please click the question box as indicated in the diagram on your screen and type your question in the bottom box. Only the presenter will see the question and the sender will be anonymous to the other attendees. So we have one question coming in here. Question is, how common is it to use a new polymer like Kraton MD1623 as an additive to my higher viscosity grades of Kraton G1652 to get a lower viscosity, lower VOC formulated adhesive or coating?
Yep, Bob, so that's a great question. It is quite common to blend some of the newer Kraton polymers with some of the more conventional ones. So one benefit of using many of the Kraton polymer products is that they are compatible with one another. So that could be a very useful technique in order to do that. And it really depends on what the I'm trying to think of the word here, what's trying to be achieved, right? What kind of property sets are exactly being investigated? But yeah, we can certainly mix some of the polymer grades in order to obtain unique property sets that maybe you're unable to obtain with the individual grades. Great question.
Thanks, Aaron. The next question is, when making a peelable film based on Kraton G1653, is the type of film extruded or can it be cast from a solvent solution? If from a solvent solution, is the Kraton polymer typically modified with a hydrocarbon resin to affect adhesion and or tear strength?
Yep, so it could be either or. G1653 can be extruded as a film, so it can be extruded as a cast film, for example, or it could be I guess kind of solvent cast as well too. So in either case, a hydrocarbon resin could be used in order to change the adhesive properties and the tear strength of that film. Whether it's either extruded film or solvent, it would still kind of go along the same lines as the hydrocarbon resins can still be added either way. Yep.
Another one for 1653, Aaron. Is G1653 food contact compliant under CFR 21-175.300? And same question for some of these new development SEBS products. Is FDA compliance expected?
So for G1653, we do have several FDA, it is FDA compliant under several regulations. I know we are specifically compliant with 175.300, I believe it's subsection B or something like that. But yeah, we can certainly get a product regulatory request in. That way we can kind of give it to whomever asks that and just give them all of the, which that grade is compliant under which regulations. Yeah, but in general, yes. And as far as I think the question on the newer developmental products, MD 1648 may, would have to check on that. I think it probably will, but again, I have to check. On MD 1623, that one may not since it's new, but again, it's something we can certainly check.
Great. The next question in the queue here is preferred resin chemistries for reducing solution viscosity of your SBS products. Is 1653 et al. Not sure about that one.
Yeah, so yeah, I mean, there's different, so typically when we add, I'm not sure what the question is referring to with specific resin chemistries. If you're looking at reducing solution viscosity, any kind of hydrocarbon resin that is typically going to be lower molecular weight than the Kraton polymers will reduce the solution viscosities, right? And it depends on what solvents they're in. If we're talking solution viscosity, if we're in aromatic based solvents like toluene, xylene, if it's a VOC based solvent, some of those hydrocarbons may have different effects depending on what solvents they're in. But typically likes like, right? So if you have a hydrocarbon based solvent system that is more aliphatic in nature, then the hydrocarbons that are also more aliphatic in nature, the resins thereof would typically lower the solution viscosity. Yep.
Great.
Assuming that's kind of what the question was referring to.
Yep. Sounds like you hit it, Aaron. The next question in the queue here is, can DX222 be dissolved in an acrylic monomer using the acrylic monomer as a solvent?
Yeah, that's an interesting question. So that I do not know. I don't know if we looked at that specifically. So yeah, I don't know. I mean, we can certainly maybe get that person some samples if that helps. But yeah, I don't know specifically whether we looked at that. So I can't say one way or the other. It's possible it may be, but it may not be.
Okay. Next question here, Aaron. I know you have several functionalized versions of SEBS products. Is there a high flow functionalized grade available? And would you be able to cross-link that for higher temperature applications?
So another great question. I believe we do have a newer high flow grade available. I'd have to double check on that, but I'm like 99% sure we do have one available. Whether they can be cross-linked, certainly if you can use the maleic anhydride chemistry on that backbone and utilize that to increase the set, you could, but it wouldn't be the same cross-linking chemistry as like our USBCs. Like with the cross-linking chemistry for DX222 will be a little bit different versus the cross-linking of some of our malleated grades. Like the traditional one would be FG1901, but yes, I do believe we have another higher melt flow version available.
Okay. The next question here is, what type of solvents would you recommend for using in these low viscosity materials for a solvent-based sealant? Can you use exempt solvents to achieve low VOCs? And would any of these polymers be more soluble than others in exempt solvents?
Yep, great question. So, so to achieve the lowest solution viscosity, typically we have to use some of the newer Kraton grades that are highlighted in this presentation. G1653, MD1648, MD1623. Typically, you'll achieve the lowest solution viscosities in the solvents that are most compatible with these polymers. Typically, that's going to be toluene, xylene, THF, things like that. Once we start adding in the VOC exempt solvents, they're typically a little bit less compatible. So your viscosity typically goes up. In fact, we we have a great presentation on a lot of data for that specifically. And as far as the compatibilities between the grades, they're quite similar. There can be some differences. So, some of our grades have different polystyrene contents and things like that. But one thing we have noticed is, in general, the functionalized Kraton products are generally not very compatible with the VOC exempt solvents, whereas some of these SEBSs, the ERS SEBSs, are a little bit more compatible with these VOC exempt solvents. But usually you'll see an increase in viscosity, but there's some tricks to decrease that back down to.
Great. We have another question that just popped in. Sorry, late to the meeting. Is DX222 available again? And I think the answer to that question is yes. Talked a little bit about that.
Yep, that's correct. So we have some, I believe we have samples available. So it's not quite commercial again yet. We brought it back. There's been enough interest. If we generate additional interest, then that might can kind of fast track that, right? So, but we should be able to have R&D samples available. We'll certainly check on that. But our plan is to bring that one back again, yes.
And that kind of flows right into the next question here, Aaron. Are all of the high melt flow grades discussed here today commercially available?
I believe so. I'm not sure about MD1623. Would have to check on that. I know for sure G1653 and MD1648 are. I think MD1623 is, but would have to double check. And then all the other grades, again, the biggest exception is going to be the DX222. That one's not commercially available yet. We have R&D samples, but we do plan on having it commercial hopefully next year.
Great. Another question regarding DX222. Would you expect increased adhesion to polyolefin films by adding DX0222 to a UV curable ink?
That's a great question. That one I'm not sure about. Whether it would have the increased adhesion to a polyolefin film. Yes, possible. I don't know if we tested that specifically. So yeah, that would be something to be interested to see if that particular customer is interested to receive a sample. But yes, it's possible. And you could certainly, the beauty of DX222 is that we can still add the tackifiers to them, right? So the hydrocarbon resins and things like that. So if you did not have good enough adhesion with just a DX222 by itself, you can still mix in, whatever tackifier that's needed to help build that adhesion as well too.
Great. A question about MD1156, recommended use for nonwovens. Does the material have a low odor, and is it water white?
So it's not water white by itself, right? It can be water white once it's formulated. So it would be very, very similar to MD1155. But yeah, as far as water white, it should. As far as low odor, again, yeah, I'd have to. That depends what the definition of low odor is, right? So it would be. I would think it would be similar to our other HSBC products at this time.
And the last question I have here in queue is MD1623 and MD1648, is it dusted? Do these high melt flow polymers come with a dusting agent for flow? Aaron?
So that would be correct, yeah. So all three of those, so MD1623, MD1648, and G1653 are all pelletized, and so we do use dusting agents on those, yes.
Great. That's all the questions that we have online. what I would say is if you are interested in a sample or have questions about the materials that were highlighted today, please make sure that you contact your local Univar Solutions account manager. You can reach out to your customer service team by calling our 800 number on the slide above or visiting our website. We will be sending a survey, so please feel free to take the survey, and any questions that we didn't get to or you come up with after the presentation is over, please feel free to reach out, and we will try to get you an answer back quickly. I want to also remind you that we have the final webinar in the Adhesive Spotlight series coming up on October 13th, where Dow Chemical will be presenting solvent-free solutions for pressure-sensitive adhesives. I want to thank you again for joining us today, and I want to have a special thank you for David and Aaron, along with the entire technical team at Kraton Polymers for today's presentation. We look forward to having you join us again on future webinars. Please have a great afternoon.